What, you want to be my TA? All right, average value. This will be familiar to some of you, but others of you might be a little new. Okay, did you get this part? Do you remember?
We did. I think like chapter 6. I think the farthest we were was chapter 7.
Okay.
So.
All right. So average is defined differently depending on what kind of average you're looking for. So we have two kind of big things of average. We have average rate or slope, okay, and that was determined as f of b minus f of a over b minus a. So that's the definition of average rate or slope. So that's the average from the first half of calculus. Okay, so remember, we've got one half of calculus done. That's the half of calculus we call differential calculus, because it's all based on derivatives. There was a theorem in differential calculus which took this formula and said it will always be equal to what at least once? Yeah. Okay, the theorem said this will always be equal to f prime of c at least once. And what theorem was that called? That was the mean value theorem. Okay, good. So now we're in the second half of calculus, which is called integral calculus. And there's an average for that as well. And that average is called the average value. And the definition of average value is similar. It's capital F of B minus capital F of A over B minus A. And the capital means that you've done the antiderivative or the integral. So a more common way of showing that is the integral of f of x dx from little a to little b over b minus a. And we kind of memorized that last year as integral divided by interval. And that is the definition of the average value of something. Now for me, it helps me to understand visually what that means. And so here's the best way, and I think I explained it to you this way last year, and we'll see if it sticks a little bit. I imagine a lot of water, and either the water is wavy or the water is calm. All right, so if you've got a fish tank or something filled with water, and that water is sloshing around, and it's all making waves, okay, really sloshy water, okay? If you want to know the average value of that function that's creating all those waves, the average value would be how much the height of the water if it all settled into smooth, a smooth height. And so you take varying values and you find their average value, and so geometrically that's what that looks like. It's just the settling or the smoothing out of water. You could do it with sand, or you could do it with really anything. That's the visual of what an average value does. The math is that it's integral over interval. Now you're going to evaluate that integral over interval using your geometry and your FNint that you have done previously. Okay, so if we want to find the average value of the semicircle, 9 minus x squared, over the interval, 0 to 3. It's actually a quarter circle. Okay, the points get awarded by you setting it up and then solving it. So don't just give me an answer, but set up, because you see average value, you're going to set up the integral from 0 to 3 of the function 9 minus x squared over dx over the interval 3 minus 0. Then you're going to recognize that as being something that you could do geometry to. Square root of 9 minus x squared is a quarter circle from 0 to 3. So the integral would represent the area bounded by that quarter circle on that interval. And so the math on this is actually a geometry problem. So this will be 1/4 pi times 3 squared divided by the interval of 3. And so we simplify, we reduce a 3, and we get 3/4 pi to be the average value. All right. Another question. You can also find your average value using f and int. And when you have your calculator, I'm going to ask you a couple of follow-up questions to that too. So find the average value of f of x equals the natural log of the function x squared. Now that is not something that can be done with geometry. And so we're going to use technology to help us out on the interval of 1 to 4. And so we'll set up the integral from 1 to 4 of the natural log of the quantity x squared dx over 4 minus 1. Using our f and int, we'll have math 9 from 1 to 4 of the natural log. I get, let's see how quickly I can do this. I get 5.090 over 3, which is 1.697. Okay, this leads up to its very own version of the mean value theorem. So I'm going to scroll back up. Okay. For differential calculus, we knew that the average at least once was equal to f prime of c. That was the mean value theorem. For integral calculus, we're like up a level. Does that make sense to you? Like we're one level, we've gone up, we've integrated, we're up one level higher. And so if you do the same thing to the mean value theorem, if you go up a level on the mean value theorem, then there has to be some point, at least once, let me erase this a minute so I have room to write, where the average value would be equal to what? What's the next level up? Instead of being f prime, just regular f of c. That means that the average value must be equal to f of c somewhere. At least once, maybe more than that. Okay, visually what that means is that if I overlaid my level value, look how many times it's equivalent. It hits that function multiple times. And so what we're guaranteeing is that that will happen at least once. And so we're going to take what we got for our average value, and we should be able to set it back equal to the original function and solve for a solution, at least one solution, within the interval that we have. So we should be able to take our original function, ln of x squared, set it equal to 1.697, store that value on your calculator, by the way. I wouldn't just use 1.697. If I were you, I would store that as like an alpha A or something on your calculator so that you get the most accurate answer. And then you solve that by using e to both sides. So we'll have e to the stored 1.697. And then we'll have x to be the plus or minus square root of that. It's a little too far. E to the 1.697. Now I don't need the negative one because the negative one won't be in the interval that I'm looking at. But I should be able to find the positive one. So I'll have the square root of e to my stored answer, and I get 2.336. And for sure, I was able to solve it for a solution within that original interval. So where you're going to use your technology, storing answers to get complete accuracy. You could also do graph to solve it, sure. To find the intersection of those two. But I still would store the value and then graph the constant of A, and that would work too. Yeah?
Is this also the mean value theorem?
It's the mean value theorem for integral calculus. We're going to have a fundamental theorem for integral calculus as well, but yeah, we've got the mean value theorem for differential calculus, and this is the mean value theorem for integral calculus. But it's still true that
Because we can take this difference.
on the closed interval. Yep. Yep, very good.